Today we're going to have more practice solving word problems that involve rational numbers. And in our first example, we're told that water drains steadily out of a lock to lower a boat from one level to another. What is the boat's change in position each minute? That's what we want to know, the change in position each minute. And by looking at the picture, I can see that the boat goes down 3 feet rather. The boat lowers 3 feet, and it does that in 4.5 minutes. All right, it takes 4.5 minutes to lower the boat 3 feet. So they want to know here, which operation can you use to find the boat's change in position in 1 minute? Well, we can use division. Okay, they tell us how much it changes in 4.5 minutes. In order to get the amount of change in just 1 minute, we're going to take the feet and divide it by the number of minutes. And so in this case, since the boat is being lowered 3 feet, that's going to be represented by the number -3. And we're going to divide that distance amongst the 4.5 minutes it takes to lower it, the 3 feet. So 3 divided by 4.5 is our problem, the number of feet per minute. And so I'm going to change everything into fractions first. -3 is the same as -3 over 1, divided by 4.5 is the same as 9 halves. And then instead of dividing by 9 halves, I can multiply by the reciprocal of the divisor. So this is going to be -3 over 1 times 2 over 9. Looking at my numbers, before I multiply, I see I can simplify. 3 and 9 have a common factor of 3. 3 goes into 3 once. 3 goes into 9 3 times. And now I'm ready to multiply. In the numerators, 1 times 2 is 2. In the denominators, 1 times 3 is 3. And a negative times a positive is negative. And so we get an answer of -2/3. Okay, so we can say that the boat lowers 2/3 of a foot each minute. In the next problem, you're told that a weather balloon ascended from an elevation of 18 feet below sea level to an elevation of 19.5 feet above sea level. And they want to know, what distance did the weather balloon rise? And in order to remember what we did last time, if we have the distance between 2 points, in order to find the distance between 2 points, all you're going to do is subtract the numbers. Okay, subtract the numbers, but then remember, we're finding a distance, and distances can only be positive. So to ensure that we get the positive answer here, once we subtract the numbers, then we're going to find the absolute value. Absolute value, again, is the number's distance from 0, and distance, again, is always a positive value, so that's what we're going to use, absolute value. And so let's set up our problem. Again, all I'm going to do is subtract the numbers first. Okay, so 18 feet below sea level is represented by -18. And now I'm going to subtract the other elevation, which was 19.5 feet above sea level. Okay, so that's my subtraction problem. And I'm going to put it inside of absolute value bars just to make sure that I end up with a positive answer. Okay, I'm going to rewrite my subtraction problem as an addition problem. I keep -18 the same, and I add the opposite of 19.5, which is -19.5. And again, this is all still in absolute value bars. If I look at my addition problem, these numbers have the same signs, so I'm going to add them together. So this is going to give me the absolute value of -37.5. And this is why we needed to take absolute value to make sure that we would end up with a positive number here. When I take the absolute value of -37.5, that gives me 37.5. Okay, and so the question wanted to know what distance did the weather balloon rise? We can say that the weather balloon rises 37.5 feet. Example 2 tells us that Kevin played a trivia game on his phone. Each correct answer is worth 2 1/4 points, and each incorrect answer is worth -1/2 point. What is Kevin's score? That's what we need to figure out. And so we're looking at the picture, and we can see that for the total correct, Kevin had 15 right. For the total incorrect, he had 15 wrong. And so they tell us up here that each correct answer is worth 2 1/4 points. So I'm going to have to multiply 15 by 2 1/4 to figure out how many points he's going to get for his right answers. And then I'm going to have to add the amount that he's going to have to take away from his wrong answers. All right, each wrong answer is worth -1/2 a point, so we're going to do 15 times -1/2 because he had 15 wrong answers. All right, so now what I'm going to do, I'm going to change everything into just fractions. 15 is the same as 15 over 1 times 2 1/4, which is 9/4, plus, again, 15 is 15 over 1 times -1/2, was already a fraction. All right, and now I'm going to do my multiplications. All right, 15 times 9 over 4, nothing simplifies, so I'm just going to multiply. That's going to be 135 over 4 plus 15 over 1 times -1/2. Again, nothing simplifies, so I'm going to just multiply those together, and that's going to give me -15 over 2. All right, so now I need to add these two fractions together, but remember, in order to add fractions, you need common denominators. Fourths and halves, I'm going to use fourths. So this will stay 135 fourths plus -15 over 2 is going to turn into -30 over 4. All right, so I've got my common denominators. This is a positive, this is a negative. They're different signs, so I'm going to end up subtracting here. And 135 fourths plus -30 fourths is equal to 105 over 4. And now all I have to do to figure out my answer is convert this number into a mixed number. All right, well, 4 is going to go into 105 26 times. Okay, 26 times 4 is 104. We had to get to 105, which means that there was 1/4 still left over. And so now we can say that Kevin's score is 26 1/4 points. In the next problem, we're told that Rashida played the same game and had 18 correct answers and 12 incorrect answers. So we want to know what Rashida's score is. So we're going to set it up just like we did with the last one. She had 18 correct answers. Each correct answer was worth 2 1/4 points. So I'm going to do 18 times 2 1/4. And then I'm going to add to that the amount for the incorrect points. There were 12 incorrect questions. Each one is worth -1/2 points. And so there's our initial setup. I'm again going to change everything into fractions first. This is going to be 18 over 1 times 9/4 plus 12 over 1 times -1/2. All right, now this time before I multiply, I can do some simplifying. 18 and 4 have a common factor of 2. 2 goes into 4 twice and into 18 9 times. 2 and 12 also have a common factor of 2. 2 goes into 2 once and into 12 6 times. And now I can multiply. 9 over 1 times 9 over 2 is going to be 81 over 2 plus 6 over 1 times -1 over 1 is going to be -6 over 1. Okay, and now in order to add these fractions together, I once again need common denominators. I'm going to use 2 as my common denominator. 81 over 2 plus -6 over 1 becomes -12 over 2. They're different signs, so I'm going to subtract. And this leaves me with 69 halves, which when I convert it back to a mixed number is going to be 34 1/2. And so I can say that Rashida's score is 34 1/2 points. Example 3 tells us that the temperature at 4 p.m. was 2.5 degrees Fahrenheit, and it dropped 75 hundredths degrees each hour for the next 4 hours. So I want to know what will be the temperature at 8 p.m. Okay, so I'm going to have to take my starting temperature, which is the 2.5 degrees. All right, and then I'm going to have to figure out what the change in the temperature is going to be. They tell us that the temperature dropped 75 hundredths degrees each hour for the next 4 hours. So I'm going to say 2.5 plus 4 for the 4 hours times, if the temperature is dropping, it's going to be a negative 75 hundredths. Okay, so I first have to figure out what this change in temperature is going to be. I have to do 4 times negative 75 hundredths first. So when I do that, okay, I'm going to have 2.5 plus something. Well, negative 75 hundredths times 4. 4 times 5 is 20. 4 times 7 is 28. Add 2 is 30. Carry our 3. 4 times 0 is 0. Add 3 is 3. And there's 2 decimal places here, none here. That's a total of 2, so I move it in once, twice. And a negative times a positive is a negative, so that's really the number negative 3. So I have 2.5 plus negative 3. All right, these are different signs now, different signs. I'm going to subtract. 3 minus 2.5 is a half. And it's going to be a negative number since the negative number has the greater absolute value. And so this tells us what the temperature was. The temperature was negative a half a degree Fahrenheit at 8 p.m. The next problem tells us that the temperature at 10 a.m. was negative 3 degrees Fahrenheit, and it increased 2 and 25 hundredths degrees each hour for the next 5 hours. What's the temperature going to be at 3 p.m.? So we're going to have a similar setup here where our starting temperature is negative 3, and we have to add the change. Well, this time it's going to happen over 5 hours, and each hour it's increasing 2 and 25 hundredths degrees. So this is going to be a positive 2 and 25 hundredths. So again, we have to figure out what this change is going to be first. We're going to have negative 3 plus something. All right. If we do 2 and 25 hundredths times 5, 5 times 5 is 25. 5 times 2 is 10. Add 2 is 12. 5 times 2 is 10. Add 1 is 11. And there's 2 decimal places in this number, none in this number. That's a total of 2. So I move it in once, twice. And so it's going to increase 11 and 25 hundredths degrees over those 5 hours. Now to get the temperature, I'm just going to combine these numbers. Again, they're different signs, so I'm going to subtract. 11 and 25 hundredths minus 3 is 8 and 25 hundredths. And this time it's a positive number because our positive number has the greater absolute value. So we can say that the temperature was 8 and 25 hundredths degrees Fahrenheit at 3 p.m. Example 4 says that the temperature at the beginning of a science experiment was 83.5 degrees Fahrenheit, and during the 4.5-hour experiment, the temperature of the liquid was decreased at a constant rate until it reached 76.75 degrees Fahrenheit. What was the rate of change in the temperature each hour? In order to figure that out, we first must figure out what was the total change in temperature. So I'm going to go ahead and subtract my starting temperature and my ending temperature. 76.75 is the same as 76 and 75 hundredths. So let's first figure out what this change is going to be. From the subtraction, I see that the temperature changed 6 and 75 hundredths degrees, and they told us that it was a decrease in temperature. So now I'm going to take that total change and I'm going to rewrite it as a fraction. This is negative 6 and 3/4. And to get the total rate of change each hour, I'm going to divide that change by the number of hours, which they told us up here it was a 4.5-hour experiment. So now I'm going to go ahead and do this division so that I can figure out what the total change is going to be each hour. So when we do the division, don't forget to change everything into fractions first, and then we're going to multiply by the reciprocal of the divisor. So it was negative 27/4 times 2/9. 2 and 4 simplify with a factor of 2. 9 and 27 simplify with a factor of 9. And when we multiply, that gives us -3/2, which is -1.5. So the temperature dropped 1.5 degrees each hour.